Welcome pre-cal students to the homework help video, page 600, 7 through 27 odd, skipping number 21. Let's go ahead and get started. Number 7. Okay, we are graphing a tangent function. And so anytime you're graphing a tangent function, the first thing you want to do is you want to find your two intercepts, or excuse me, your two asymptotes. We're going to grab this and bring this up here. And bx minus c is simply x. That's pretty easy. So x equals negative pi over 2, okay, or negative 90. And then we're going to take this formula here and we're going to find the other asymptote. Bx minus c is simply x, so x equals pi over 2 or 90 degrees. Well, that's pretty simple. My goodness. So here we're going to put, I'm going to go ahead and use degrees because degrees are a little easier. I'm going to go ahead and put negative 90 degrees. And then right here I'm going to put positive 90 degrees. So it looks like to me the period is 180 degrees. Does everybody see that? Okay, I hope so. Because from 90 to 0 is 90, and from 0 to 90 is 90 more. So the gap from here to here, from asymptote to asymptote, is 180. Okay, so we're going to go ahead and put our asymptotes there very quickly. There we go. And I've told you guys you only have to do 3 sets of these graphs, so there's one set. Now we're going to add 180, so if we go over here it's going to be 270. Because remember, in this problem here, the asymptotes are taking place every 270 degrees, okay? 270, all right? Now let's come over here and put negative 270, or if you want to put negative 3 pi over 2, you're welcome to do that for 270. It's totally fine. And then, of course, let's find our middle value right here, which is 0. So I'm going to put 0 in for x. So 1/3 tangent of 0. 1/3 tangent of 0 gives you 0. And then go to the right just a little. I'm going to put 89 degrees, and I'm going to get real close to the 90s. I'm going to put 1/3 tangent of 89 degrees. You could have used anything from 0 to 90. You could have used 20, 30, 40. I'm just going to get real close to the dotted line. 89, I get out 19, positive 19. So when I go this direction, I'm going up. So I know the graph will be up here. It'll curve down, it'll hit here. It'll look like that. And that's good enough for me, students. I'm not going to be too picky on these, okay? So here's your middle value. It'll come down, hit here, curve here. Wow, that's beautiful. Just kidding. Come down, hit here, curve this way, and there we go. Moving on to number 9. All right, we have a tangent graph again. So there's one asymptote formula. Here's the other asymptote formula. Let's see what we have here. We have bx minus c would be 3x. So very quickly, I'm going to put 3x equals negative pi over 2. I'm going to divide both sides by 3, and you will get out negative pi over 6, or negative 30 degrees. Now we're going to come over here, we're going to put 3x equals pi over 2. We're going to divide both sides by 3, and we're going to get x equals pi over 6, or positive 30 degrees. So I'm going to put negative 30 degrees here. You're welcome to use ratings if you want to. It's just easier sometimes to use degrees because we're going to be counting over and finding the middle value and stuff like that, but it's up to you. Now, students, it looks like to me the period is going to be 60 or pi over 3 if you prefer, because from 30 to 0 is 30, and from 0 to 30 is 30, so 30 plus 30 is 60. So I'm going to add 60 or subtract 60, however you want to look at it. So here's my asymptotes right here. Once you find the set of asymptote, students, it's really, really not difficult to do. And remember, I would like 3 sets of these if at all possible. 3 sets, okay? From now on, I really believe I need to probably erase this stuff up here so it's not so sloppy. And that'll do for this problem. All right, now here we go. Okay, now the middle value between 30 and 90 is 60. So I'm going to put 60 in for x right here. Okay, so tangent of 3 times 60, 180 degrees, is going to be 0. So we're going to have 0 right here. Now, personally, you can put any number into your function that you want between 60 and 90. I'm going to use 89 degrees just to see what happens when it gets real close. So tangent of 3 times 89 is 19.08. So when I go over, I'm going up. And that's all I need to know. So the graph will look something like this. Now, some teachers want you to be a little more specific on how quickly does it shoot off quickly and go up, or a little more gradual. I'm not too worried about that, to be honest with you, students. That's definitely sufficient, okay? All right, number 11. Now remember, on number 11, it's a secant it's a secant graph, so we're going to rewrite it and pretend that it's a cosine graph, the reciprocal function, okay? And then we're going to use our normal steps for cosine, and then we'll see if we have to extend the y-axis, see if there's a shift or something like that, okay? So we're going to check for a vertical shift and find the amplitude and put our dotted lines on the graph. Now, students, if you look, nothing is being added or subtracted to the entire cosine function, so there's no vertical or horizontal shift. So the middle of the graph will stay right here, okay? Now, the amplitude, there's a -1/2 here, and we don't care about the negative sign. However, we know, put a tick mark here and a tick mark here, we know we're going to go up 1/2. So it's going to be a short graph. It's not going to be that tall. I'm going to go ahead and put a 1 here and a -1 here so we can see that we're going to 1/2 here. And students, we're cruising pretty well. There we go. I mean, the graph's going to be somewhere in between here, so we're doing pretty well. Okay? All right, now, step 2, we're going to find the period of the function by using 2p divided by b. Now remember, b is always the multiple or the coefficient of your x. And in this problem here, the coefficient of x is 1. So to find the period equals 2 pi over b, or 2 pi over 1. So the period equals 2 pi. Okay, let's not forget that. Now let's move on to step number 3. Find a key point by solving bx minus c equals 0. So remember, bx minus c is the entire expression that you're taking the cosine of. In this case, it's just x. So bx minus c is x. So x equals 0. Pretty simple, okay? So we know the x value we want to use is 0. So I'm going to put a 0 comma right here. And now let's go and put 0 in for x. So 1/2 cosine of 0, -1/2. So -0.5. Make sure you're in degrees if you want to be in degrees, or radians if you want to be in radians, up to you. -0.5 cosine of 0 gives you -0.5, or -1/2. Now, students, remember, to find the second key point, you take the value from step 2, which is your period, and divide it by 4. So we have 2 pi over 2. Always take your period, divide it by 4, and you'll get pi over 2 if you reduce it. So pi over 2 would be your x value. If you want it in degrees, that's totally fine. I have no problem with degrees. It would be 90 degrees. Okay? So here we go. Let me get a drink here real quick. I don't mind pi over 2 or 90, so cosine of 90 degrees. So -0.5 cosine of 90 degrees gives you 0. So now, using these critical values, I'm going to sketch a dotted graph, because remember, students, the original function was not cosine. The original function was secant, okay? And so we're not really graphing cosine. Cosine is just some boundaries we're setting up to help us graph the secant, okay? So 0, 1/2 would be right here. 90, 0. Let's go ahead and call this 90 right here. 90 zeros right here. So it looks like to me we're going to add or subtract 90 over and over and over. So that would be here. And to be honest with you students, really I need to stop and make sure we do something here. It's my fault and I apologize. We always need to keep these tick marks here, 90. So when you set up your original coordinate plane, you do want to have 90 here, 180, 270, and 360, or pi over 2, pi, 3 pi over 2, and 2 pi. Same thing over here, only negative values. So don't think we're making this 90 here because this was 90. If this 90 here would have been a 45, I still would have made this a 90, and the point would have been slid over to here. You'll see what I'm talking. We'll do more of these later. You'll see what I'm talking about. But moving on, so 90, 180. This would be 270, and then this would be 360. All right. So just we go high point, middle point, low point, high point, middle point. I'm not going to fill these in. You know it's negative 90, negative 180, negative 270, negative 360. So we go here, then we go over 90 down, over 90 up, over 90 up. Now, I'm going to go ahead and sketch the graph, but it's going to be a dotted graph. And it's really important you do that in your tests and quizzes because I want to make sure that you're telling me that you know this is not the original graph. There. Now, remember what to do next, I hope. You put asymptotes on every point that's right in the middle. So every point that's right in the middle that lies right on this middle dotted line, you put an asymptote. So you're looking for points that lie on this middle dotted line. Here's one. So we'll put an asymptote there. Okay. Here's one. So we'll put an asymptote here. Here's one. So we'll put one here. And now in blue is the final graph. So here's a high point right here. So you draw a parabola like this. That's good enough. Then here's the next point. It's a low point. So you sketch a parabola here. And then here's the high point. So you sketch a parabola here. Here's a low point. So we'll sketch a parabola here. Here's a high point. We'll sketch half of a parabola since we don't have the other boundary over here. And there you go. That's it, students. Okay, so the actual graph of the secant function is the blue part of the graph. Okay? All right, let's continue on to number 13. Okay, students, first of all, we're going to take our cosecant and we're going to pretend it's a sine, which is the reciprocal function of cosecant. Okay? Very important you get that right. And then let's go ahead and do step one. Check for a vertical shift and find the amplitude. Well, if you look, students, nothing is being added or subtracted to this function, so we know there's no vertical shift. Also, the multiple in front of the sign here is 1, even though you can't see it. So what that tells us is we have no vertical shift. And we're going to go up 1. And we went up 1 because the multiple right here next to the sign is 1. And then we're going to go down 1. Okay? There we go. All right. Now, number 2, find the period of the function. Okay, so here we go. 2 pi over b. Now, b is always your multiple, or your coefficient of the x. So 2 pi over, and what's the coefficient of the x? Pi. So 2 pi over pi, so your pi's cancel, and your period equals 2. So this is going to be one of these problems where the period is not in terms of pi, it's just in terms of numbers. Okay, so we're going to have to be really careful on this. So your period is 2 radians. Now, step 3, find a key point by solving bx minus c. So bx minus c is whatever you're taking the sign of, the whole quantity. So we have pi x, that's bx minus c equals 0. Divide both sides by pi to see what x equals and x equals 0. So your ordered pair is 0 comma something. All right, so I'm going to go ahead and put 0 in for my x. And of course, pi times 0 is 0, so you're really taking the sign of 0. So the calculator here, sign of 0 is 0. So when I put in 0, I get out 0. Now step 4 says find another critical key point by taking the value from step 2, your period, and dividing it by 2. So 2, or dividing by 4. So 2 divided by 4 is 1/2. So we're going to add a half. Okay. So my next ordered pair would be 1/2 comma something. Okay. So I'm going to come over to my x here. I'm going to put 1/2 in for x. So I have sine of, now be careful, make sure you're in radians. I mean, just make sure that as you type these into your equation, if you're putting 1/2 in, remember that is radians. Okay, please keep that in mind. So my advice to you, let me pause and say this, students, you are not to use radians because there's a pi here. That pi is nothing more than a multiple. You're to be in radians because when you solved your period over here, you got out 2, and that wasn't degrees. Let's go back to the last problem. When we found the period over here, we had 2 pi, okay? And then we converted that over to degrees later, okay? But in this problem here, we're in radians right now, okay? There's no degree symbol with this 2, okay? So you're in radians, so I'm going to go to my calculator right now. I almost forgot to do this and put it in radians. And now I'm going to type into my calculator sine. You said, Mr. Earhart, when you put 0 in, you weren't in radians. That's because 0 degrees is the same thing as 0 radians. So your calculator sees no difference. When it's 0, it's 0. 0 degrees is 0 radians. But 1/2 radians is not the same thing as 1/2 a degree. So here we go. Sine of, and then we have 0.5 pi, and I'm getting out 1. So we'll put a 1 here. There we go. Now, students, I just said in the last problem, you really need to keep these 90, 180, watch this, or in other words, pi over 2, right? Sure, pi over 2, pi. Well, students, come on, think about this. What is pi over 2? 1.57. What is pi? 3.14. So in these types of problems here, I'm trying to help you. I'm not trying to be tougher. I'm trying to be easier on you guys. Listen, whenever your x value is in radians, but there's no pi, it's not radians in terms of pi. It's just radians. I want to give you a little leniency and allow you to make these values, instead of 1.57, make it 1. Make this, instead of 3.14, 3. You can put a 5 and you can put a 7. I'm okay with that. That's really going to help you, students. It really will. Okay? -3, -5. Now, once again, for the third time, you only do this to help you when your x values are in radians and the radians are not in terms of pi. Okay? All right, so my one ordered pair is 0, 0. My other ordered pair is over 1/2 and up 1. So I'm going to continue to go over halves and then move over 1/2 and then here over. I got to be careful here because I'm going from, actually, students, I apologize to you and please forgive my mistake. I'm sorry. I just noticed here we're going from 0 to 1 and then we're skipping increments of 2. So let's go ahead and say that you're allowed to just go 1, 2, 3, and 4. And I'm embarrassed. I hate that when I make mistakes like this, but we all do it. So -1, -2, -3, -4. Okay, so here we go. And I apologize for that. So in these cases, once again, when your x value is in radians and it's not in terms of pi, then you're welcome to go 1, 2, 3, 4. I have no problem with that at all, students. Okay, it'll be easier for you. All right, so here we go. Let's go ahead and put a point here at 0, 0, then over 1/2 and up 1, over 1/2 then here, over 1/2 here, over 1/2 up, over 1/2, over 1/2, over 1/2, and over 1/2. Okay, and the same thing here, over half, and over half. And every time you go over half, you're either moving to the top or the middle or the bottom of your dotted lines, okay? I'm not going to try to get the Mr. Lemon Art of the Year award. I'm going to go really fast here. Just put a quick dotted graph. There we go. I'm going to put straight lines for my asymptotes. Your asymptotes are always where the points are on the middle dotted line. I'm going to make my asymptotes a little better here, I believe. Hopefully I can do that. Yeah, it's a little better. Looks like we missed one over here, right here. And we missed one over here. Sorry about that. And one here. And it looks like one here. Students, I put an asymptote where there's a point on your middle dotted line. Hopefully I didn't miss it. If I did, I apologize, but I think we're okay. And so here's a high point. Let's see, this one here. Yeah, this one here should be slid over to right there. All right, sorry about that. And here we go. So there's one parabola here. Again, students, the faster I go, the faster the video goes, which is a help to you. So I'm not condoning being sloppy. I want yours to be pretty neat. Reasonably neat. So there we go. And there we go. Okay, moving on to number 15. All right, now 15, I'm pretty sure this, well, we'll get to that in a second. So 15 is going to be a secant function, which is a cosine. We're going to use cosine, the reciprocal of secant. And so let's jump right into this. Here we go. First of all, the first thing I want you to notice is there is something being added or subtracted to the cosine function. It's -1, so we're going to have a shift going downward, okay? So we'll put a -1 here, and that's where the middle dotted line will go because I have a -1 here. Now, students, you might be saying, well, Mr. Air, how do you know it's not cosine of pi x minus 1? Because there's no parentheses around it, okay? In other words, another way to write this would be y equals -1 plus cosine of pi x. Hopefully that helps you see that a little better, okay? All right, so continuing on. So I'm -1, and then the multiple in front of the cosine is 1. So I'm going to go up 1 to the x-axis. I'm going to go down 1 here on the y-axis, and there we go. My graph takes place somewhere between these dotted lines, okay? Now, step 2, find the period. So we're going to take 2 pi over the x coefficient, which is pi again. So here we go, same thing. These will cancel, so the period equals 2. So once again, I'm going to let you use 1, 2, 3, and 4 here on your x-axis. So your period is 2 radians. Now, number 3, find a key point by taking bx minus c and setting equal to 0. Remember, you're not taking the cosine of -1. There's no parentheses around this. Okay, so really, sorry, students, really, your bx minus c is just pi x. So you have pi x equals 0. Divide both sides by pi, and x equals 0. All right. So students, here we go. So your x value will be 0. So my key point will be 0 comma something. So let's put a 0 in for x. And remember, again, you're not taking this whole thing in parentheses here, okay? I really think it would be wise to rewrite this function like this. I really do. Y equals -1 plus cosine of pi x. That's up to you, okay? So we're going to put 0 in for x. So with my calculator, I'm typing -1 plus cosine of 0 times pi, which is 0, and I'm going to get out 0. Okay, so 0, 0. Now we're going to find a second key point by taking our period, dividing it by 4 like we always do, and we get out 1/2. That'll be my next x value, so 1/2. And then I'm going to put 1/2 in for x, so here we go. I'm going to type into my calculator -1 plus cosine, and then 1/2 pi, so 0.5 pi. Make sure you're in radians, of course, students, and you'll get out a -1. So here we go. One key point is 0, 0, and the other one is over half -1. I'm going to go ahead and put a 1 here, a 2, a 3, and a 4. All right, and then a -1, a -2, a -3, and a -4. So 0, 0, 1/2 -1. We're going to keep going over halves. And every time we go over half, we're either going to the top, the middle, or the bottom, okay? All right, go over half here, go over half. All right, that's pretty good right there, students. All right, now, everywhere there's a point on this middle dotted line is where you want to draw an asymptote, okay? So here we go. I'm going to do this once. I'm going to copy it. And I'll put the asymptotes in place. So here we go. All right, let's do this very quickly. So here we go. Here's one asymptote. Another asymptote. Everywhere there's a point on this middle dotted line, I'm going to put an asymptote, okay? Looks like we have one too many, I believe. And then very quickly, students, again, I'm not condoning being sloppy, but I am trying to be fast here. You draw your parabolas, okay? At the high point and the low points on your top dotted lines and your bottom dotted lines are where you will put your parabolas, okay? Moving on. All right, here we go. Number 17. All right, cosecant. Here we go. Now we're really going to try to pick up the pace now, students. Here we go. The reciprocal of cosecant is sine, and so we're going to check for vertical shifts. There's nothing being added or subtracted to cosecant or sine, so no vertical shift. The multiple in front of the sine is 1, so we're going to go up 1, down 1, and put some very quick horizontal asymptotes here, top and bottom, and then we'll put a dotted line for the middle of the graph, and our graph will go in here somewhere. Step 2, find the period. So the period is 2 pi over b. Now remember, students, x over 2 is the same thing as 1/2 x, so your coefficient of x is 1/2. So pi over 2 over 1/2, and pi divided by 1/2 is 4, so your period is 4 pi. No, notice this time, listen, students, this time we have period in terms of pi. So if it's in terms of pi, please feel free to use radians. I mean degrees. Please feel free to use degrees. So your period is 4 pi or 720 degrees. Now, step 3, find a key point by taking your bx minus c. Your bx minus c is x over 2. That's what you're taking the cosecant of, or the sine of, equals 0. Multiply both sides by 2. X equals 0. So your key value for x is 0. Now we're going to put a 0 in for x right here. Okay, so we have sine of 0, which gives us 0. Now, to find your next key point, you take your period and you divide it by 4. So divide this by 4 and you get pi, or you can divide this by 4, same thing, and you will get 180 degrees. I'm going to use degrees. Degrees is a little easier, so 180 degrees. Now remember, when you're in degrees, I want these to always be the same here, okay? 90, 180, negative 90, negative 180, etc., okay? So now, students, make sure that your calculator's in degrees, okay? Make sure you're in degrees, because you're going to put 180 into axis degrees, and now we have the sine of 180 divided by 2, which is 90, so the sine of 90 gives you 1. And now we are so ready to roll. Here we go, 0, 0, 181. So it looks like we're going to add 180 every time. So go over to 360, and we'll be right here. This will be a really spread out graph, okay? All right. 0 to 180 is here, then to 360 is here. So we only need 3 asymptotes, okay, just 3. So here's 1, and I'll fix that in a second, okay? Let me quickly copy that. Actually, we'll just draw 3 of those and slide them around. So there's another one, and there's another one. Okay, so your asymptotes go on the points on the middle dotted line. So there's 1, and the next middle dotted line would be right here on the right on top of the y-axis, and then your next middle point would be right here. So this is really a spread out graph, which is fine. So you have a low point here, so it's going to be kind of a fat, wide parabola there, okay? There we go. And then we have 1 right here. And that's sufficient, students. That's all you have to do, okay? No problem on that one. All right, number 19, cotangent. Now, when you're dealing with a cotangent or a tangent function, you want to find the asymptotes. So here's the formulas you use when you're dealing with cotangent, okay? I guess we forgot part of the formula. There we go. So here we go. Bx minus c would be x over 2. So x over 2 equals 0. Multiply both sides by 2. And x equals 0. So there's 1 asymptote. Now, let's see. Once again, we use x over 2 for bx minus c equals pi. Multiply both sides by 2, and the other asymptote is going to take place at 2 pi, or in other words, 360 degrees. So I'm going to put a point here at 0. And I've told you on your tangent and cotangent graphs, what I would do is I would skip a point, so you have a middle value, and then put the next asymptote. Okay, so 360. That's really how I recommend you do these, okay? And you only need 3 of these. Not 3 asymptotes, but 3 sets. So you've got a graph here, and now let's do one more over here, negative 360, okay? On a test or a quiz would be really helpful if you labeled your asymptotes, okay? Now, we got to find the middle value here. Of course, from 0 to 360, the midpoint would be 180. So I'm going to put 180 in for x. 180 divided by 2 would be 90. So I'm going to take the tangent of 90, and I get undefined. So if the tangent of 90 is undefined, the reciprocal of undefined is 0. So I'm going to get 0 right here. And then I'm going to put in 359 degrees. Now you can put in any number you want between 180 and 360 to see what the graph is doing in the space right here. I'm going to use 359, so I'm going to type in tangent of 359 divided by 2, and I'm getting negative 0.008. So as I go to the right, it's going down, okay? So as I go to the left, it's going up. So the graph would look something like this. Here we go. And students, we are ready for number 23. Here we go. All right. The tangents and cotangents are so much easier. I'm sure you guys agree with me on that. So I would much rather do these than the sine or cosine or secant or cosecant. But anyways, here we go. Let's go ahead and find our 2 asymptotes for tangent. Bx minus c will be pi x over 4. So I have pi x over 4 equals negative pi over 2. Now it looks a little confusing, but students, don't freak out here. It's pretty simple. Okay, let me get a drink here. First of all, you want to get x by itself. So I'm going to multiply both sides by 4. If you multiply the left side by 4, you get pi x. If you multiply the right side by 4, you get negative 2 pi, okay? Because this times 4 over 1, your 2 would cancel into your 4, you get 2 pi, all right? Now, next, I'm going to divide both sides by pi. X equals negative 2, so there's one asymptote there, okay? Now let's come over here, and let's take, again, pi x over 4 equals pi over 2. Multiply both sides by 4. You get pi x equals 2 pi. Divide both sides by pi, and x equals 2. So I'm going to go ahead in this situation here. Notice, students, that you have radians. Just like the last problem, we had radians. Right here we had, well, we had 2 pi, and we converted over to degrees. Because whenever radians is in pi, it's so easy to convert it over to degrees. But here, if it's radians not in terms of pi, I'm just going to leave it whole numbers, and I'm going to let you guys just put 1, 2, 3, 4, etc. It's totally fine with me. I'm just going to let you put numbers on the x-axis. So here we go. We have a intercept negative 2. I'm going to put it here. And here's my middle point between the two asymptotes, and then 2. So students, it looks like to me from 2 to 0 is 2, and from 0 to 2 is 2 more. So my period is 4. So every asymptote is going to take place at 4 more. So 2 plus 4 would be 6. And negative 2 moving 4 to the left would be negative 6. So there's my asymptotes right there. And notice how I have 3 nice sets of graphs, or 3 spaces for my 3 graphs. Okay, now let's go ahead and use this for my example. I'm going to put in a 4, because 4 is right in the middle of 2 and 6. Take 2 plus 6 divided by 2, you get the average, which is 4. 4 is in the middle. So for x right here, I'm going to put in 4. Now make sure, right now I'm grabbing my calculator, students, make sure that you're in radians and not degrees. Okay, I'm changing mine right now. Okay, here we go. So I'm going to type into my calculator tangent, and then 4 pi divided by 4, and then close my parentheses, and I'm getting out 0. Okay, so it is 0. Now I'm going to get real close to 6. I'm going to put 5.9. If you want to put just 5, that's totally fine, okay? I'm going to put 5.9 for x. So I'm going to put I'm going to put tangent 5.9 pi, and then divided by 4, and I'm getting 12.70. So when I go this way, the graph is going up. So the graph would look like this, starting here, hitting here, and coming down, starting here. I missed my point here, but you get the idea. Coming down like that, okay? All right, moving on to 25, and then 27 will be finished, okay? All right, for number 25, we have cosecant, so we're going to change that to a sine, okay? And here we go. Number 1, I see nothing being added or subtracted to the entire function, so there is no vertical shift. There's a multiple or a factor of 1 in front of sine, so I know I'm going to go up 1 and down 1. So here's my middle dotted line right here, lying on top of the x-axis. Then I go up to 1 on the y-axis, and then down to negative 1 on the y-axis. So I've got a nice boundary here for my graph. Number 2, find the period. So the period equals 2 pi over b. B is always, now listen students, b is always the coefficient of x. Okay, in this case it's negative x, so negative 1. Okay, now to be honest with you, the negative 1 is really not going to do a whole lot. I mean, if your period is negative 2 pi, that's the same thing as pi. All the period is saying is, look, you're going to the right 2 pi and you're going to the left 2 pi. So the negative side is really not that important. You can keep it if you want to, but it's not necessary. So your period here is 2 pi or 360 degrees. Now, we're going to find a key point. So we take the entire expression x, pi minus x, And according to step 3, we set it equal to 0. So it's a positive pi. We're going to bring the pi over and make it negative pi. So we have negative x equals negative pi. Then divide both sides by negative 1 and x equals pi. So my first key point, the x value is going to be 180 degrees. Okay, pi 180. Let's go ahead and put 180 in for my x right here. And remember, students, you are in degrees here. Okay, so be really careful with that. All right. Okay, students, I'm back, and I sensed a little problem with this problem. And when I'm wrong, sorry, excuse me, when I'm wrong, I'm wrong. But in this case here, I do have a problem with this function. Let me look in the book here and see if it says to assume everything's in radians. It doesn't say that. Really, to be honest with you, students, pi here is not necessarily in radians. It's a factor being added or subtracted to the x. But they're assuming, because there's a pi here, that we should go ahead and use pi for x. I kind of have a problem with that personally, but that's fine. Not a big deal. So because there's a pi here, we are going to use radians, which is fine. That's what the book wants on a test or a quiz. I'll make sure I'm really clear about that. So don't worry about that. So we're going to go ahead and put pi here. So make sure you're in radians. And pi minus pi is going to be 0. So the sine of pi is going to be, or the sine of 180, however you want to look at it, is going to be 0. And so, students, pi minus pi is 0. The sine of 0 will be 0. And pi minus pi is 0. Sine of 0 is 0. So when you put pi in for x, you get out of 0. Now, moving on to step 4, we're going to find a second key point by taking step 2, the period, dividing it by 4, and then adding this value to this key point here. So we have 360 divided by 4, which is 90 degrees, which is pi over 2. Or you can take 2 pi divided by 4, and you get pi over 2. Now, of course, because they want us to use radians in this problem, we are going to have to put pi over 2 over here, okay? So pi over 2. So we're going to put pi over 2 for x right here. So with my calculator, I'm typing in sine, and then pi minus pi divided by 2. Hit enter. And actually, I'm sorry, would it be pi over 2? Let's see here real quick. It would be, hold on 1 second here. We took 360 divided by 4. We got 90. So yes, we added pi over 2. So we will get out pi minus pi over 2 is 1/2 pi. So you would get 1 out. So the sine of pi over 2, because pi minus pi over 2 is pi over 2, you have 1 minus 1/2 a pi. So you get 1/2 a pi. The sine of 1/2 a pi would be 1. Okay, so we're at pi 0, and then pi over 2, 1. Now, students, listen to me. I encourage you. You are more than welcome to use degrees down here. I'm going to. That's much easier, okay? And it looks like to me we're going to add pi over 2, or 90 degrees, over and over. So one point is going to be here at 90, and then 180, 270. We're adding 90 over and over. How do I know that? Because one key value was pi, or 180, and the next key x value was pi over 2. And then negative 90, etc., negative 180, 270, etc. So 180, 0, and then 90 is up at 1. And then from there, we just quickly fill in the points, okay? Not too difficult. Looks like we're going to need 1, 2, 3, 4, 5 vertical asymptotes. So very quickly, let's get those drawn. Guess it might help to get rid of some of this up here so we don't have all this mess. And here we go. 1, 2, 3, 4, 5. And here we go. So we have an S. Remember, you're looking for the points that lie on the middle dotted line. And all of those points get a vertical asymptote, okay? And then we're ready for the final touches, the final graph. So here we go. Here's a high point here, so you have a parabola here. Here's a low point here, so we have a parabola here. Here's a high point here, so we have a parabola here. And here's a low point here, so we have a parabola here. Wow, one more problem, we're finally done. Here we go. Number 27. Okay, now first of all, we realize we're going to make this sine because it's cosecant. So there's the reciprocal function. And then next, let's put a 1 here, a -1 here. Notice that there's no vertical shift. There's nothing being added or subtracted to the entire function. However, so we have a middle dotted line right here. However, those students, the multiple or the factor times the sine is 1/4. So we're only going to go up 1/4, okay? This is going to be a super skinny, not skinny, but short graph here. Okay, it's not going to have a very large amplitude. Okay, there we go. Now, find the period, 2p over 2 pi over b, excuse me. So period equals 2 pi over b. Your b is your x coefficient, which is 1, so your period is 2 pi. Okay. Step 2, key point. We're going to take the entire expression that we're taking the sine of, x plus pi over 4 set equal to 0. Bring the pi over 4 over, and x equals -pi over 4. All right. So let's see. My x value is -pi over 4. All right. And so if I put -pi over 4 for x right here, I have -pi over 4 plus pi over 4 is 0. So I have 1/4 sine of 0. So the sine of 0 is 0 times 1/4 is 0. So you will get out 0. Now, to find my next key point, I'm going to go over to my period, which is 2 pi, and divide it by 4, which would give me pi over 2. All right. So there's my next key value, x value, so pi over 2. And so let's see here. It would be, sorry students, I apologize. We're going to add pi over 2 to this right here. All right, so we're at negative. If you want to, I'm going to quickly convert to degrees to help me. I'm at -45 degrees. Okay, that's what pi over 4 is. And I'm going to add to that pi over 2, which is 90. So I'm going to add 90 to that, and I'm going to get positive 45 degrees, okay? So remember, you take the, let me go over this again, you take the period, you divide it by 4, and you get pi over 2, or 90 degrees. So I'm adding pi over 2 to this, or I'm adding 90 degrees to this, and you come up with 45 or pi over 4. So there's your other x value, okay? Now we're going to put that in for x up here. We have pi over 4 plus pi over 4. And of course, a fourth plus a fourth is a half. So I really have sine of pi over 2 or sine of 90, depending on what mode you're in, okay? And so 0.25 sine of pi over 2 or 90 gives you 1/4. Now again, students, I'm going to make mine degrees. I really am. It's much easier. 90, 180, 270, 360. Same thing over here, -90, etc. And so my first order pair is -45, 0. Change colors here. And my next ordered pair is +45, 1/4. So I'm going from 45 degrees from here to here to 45 degrees. So my whole gap from this point to this point is 90. So I'm gonna add 90 over and over. So 45 plus 90 is 135 right in the middle. Plus 90 would put me right here. Plus 90 would put me right here. Plus 90 would put me right here. And now we're going to subtract 90. So we're at -45. That'd be -135. And then subtract 90, subtract 90, and then subtract 90. Okay, so it looks like we have 1, 2, 3, 4, 5 asymptotes. In other words, we have 5 points right here on this middle dotted line. And so let's put 5 asymptotes very quickly. And again, students, I apologize. Let's get rid of all this so it's not so messy. And here we go. 1, 2, 3, 4, 5. And let's quickly move our asymptotes. So here's one here. There's one here. One over here. One here. And one here. Okay? And wow, we're finally finished. Here's a high point here. So we'll put a parabola here. Wow, pretty bad parabola. There's another parabola, low point, high point, low point. Okay? I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.